of that time. And so let me show you a map of what the route that he took. So here is England, right? Here's England, the British Isles. He sailed. Here's the route. Must be nice, right? He sailed this route out of here, and he went all the way down to Cape Horn, South America. Now, it doesn't mean that it doesn't stop, okay? It stops at every port, okay? Because you got to stop every a month, 2 months, so that you need new supplies. And then he sailed across here, Pacific Ocean, and then all the way to New Zealand, around Australia, up to the Indian Ocean, below Africa, and then went back to England. You see what I mean? That's like almost the world. That's took 5 years. So in this journey, he saw a lot of things. He collected thousands of specimens that he observed, that he collected, animals, species that he has never seen before, plants that he dried up, that he collected and dried. Now, but one island that he went to that he was very impressed with, that he talks about a lot in his book, is right here. This island right here. It's the west coast of Ecuador. This island is called Galapagos Island. Galapagos Island is a chain of islands. It's like a dozen islands, and these islands were once inhabited by people, but because it didn't have enough natural resources, and they're not very big islands, people started moving inland to Ecuador and Chile, things like that. And so the islands were open to animals. The animals would start inhabiting the island. And what he saw was a very unique feature on each of the island. Now, some of the examples that he saw during his trip was these two. If you look at the emu of Australia and the ostrich of Asia, Africa, and the Arabian Peninsula, notice how they're almost identical, right? In terms of size. The ostrich and the emu, they're almost the same size. Now, is Australia connected to Asia, Africa, the Arabian Peninsula? No, they're very far. I mean, the body of water, the ostrich cannot fly, the emu cannot fly. And so, during Darwin's time, he noticed that they look similar to each other. They're very fast animals. But today we compare the DNA, we find that they're very related to each other. Something happened, right? Something happened. He also observed other plants and animals. Like, if you look at these beaks, look at the shape of these beaks. Very big, medium size, small, and very narrow, right? And when he collected these birds and he brought it back to the ship to analyze, he noticed they were all the same species. They're all the same species. They were finches. They were the same type of bird. But how come this bird has such a big, large beak? This one has such a medium, small, and then this one has such a narrow beak, right? So he was curious on why they were so different. Now, so he continued his journey and he went to the island. Remember, the Galapagos Island, right? The Galapagos Island. Now, on this island, he was able to island hop because they dock at Galapagos as a kind of like a rest area because it's right off the coast of Ecuador. It's safe and there's no human there, so the ship can dock and repair whatever it is they can do in that area. And so Darwin was able to travel through all the island chains. So here's a large island of Galapagos. There's a bunch of smaller islands here. There's a bunch of smaller islands, and he saw finches, these birds throughout all the islands. So all of these islands, they had these birds. At the beginning, he didn't think they were the same species, but then later on, he found out they were the exact same species. However, they were different. Notice how this one's darker, this one's lighter, this one's smaller, the beak is bigger, the beak is smaller, the beak is sharper, the beak is longer. You see what I'm doing? So then he observed the island. He walked around the island and he discovered that the reason why the beaks were different was because of the food that was on the island. Some islands were very dry because of their location, facing the sun. So fruits could not grow. So those islands for the plants to survive, they had to grow nuts, very hard shell nuts. So the island with the nuts, they had birds with big beaks. The islands that had lots of berries were the islands with smaller beaks. The islands with a lot of flour were the islands of the birds with very long beaks. You guys see what I'm doing? Now they're all the same species. They're all finches. But because over many generations, they slowly adapt to the environment that they live in. That's what Darwin observed, okay? Now, he also saw on Galapagos Island tortoises like these two guys. Notice how the neck of this tortoise. Look at the neck length. And look at the neck of this guy, short, right? This guy, very long. These are completely different tortoises. Now, he observed that on this island where this guy was living, the plants were higher. The plants, the food source was higher. Whereas on this island, the food source was on the ground. And so it makes sense for these tortoises to have shorter necks because you don't need to have long necks on this island. You should be able to survive. But if you were living on this island and you had a short neck, you're dead. You cannot survive because you can't feed yourself. You won't be able to reproduce. Now, he saw another species on Galapagos Island. It's called the anole lizards, right? These are two lizards. They're both on Galapagos Islands, different islands. Notice how the differences between them, but they're the same species. They feed differently. They adapt to the environment that they live in, just like the tortoises. Now, so Darwin, he thought about it. He's like, maybe it's just a coincidence. Maybe it's just because he hasn't been, the world is very large. Maybe because he's been to only a few places, so therefore it looks similar to him. So then he started collecting fossils. He saw this fossil right here, something similar to this. It's called Glyptodont, okay? Glyptodont is this fossil. And so what he did was he drew an illustration of what he thinks this animal looks like. So this is what they think this guy looks like, okay? Now, so he found fossils of other species. And doesn't this guy look like the armadillo? Now, during that time, he didn't have DNA knowledge, so he couldn't genetically sequence or determine the exact relationship. But today, we know that they're cousins of each other. They're cousins. They're in different areas. They live in different areas of the world. But you look at features of the armadillo and the Glyptodont. They're very similar to each other. Very similar. Now, this guy, if you look at the size, he's 3 meters. He's very big. He's this big. 3 meters. That's 9 feet long. You know what I mean? How big is an armadillo? Look, it's tiny. Maybe a foot something, 2 feet. That's a big one. But these guys are like dinosaur size. You know what I mean? Dinosaur. But it shows a relationship between the two. So Darwin started collecting a lot of fossils in his journey beyond Galapagos Island because of his travels to so many ports. Now, when he got to some of the ports, he started to hike further inland. And then as he's hiking inland, he saw fossils of species like this guy. This is a crab. And did he collect this somewhere on the coast? No. This is about 10 miles, 20 miles inland. 10, 15, 20 miles inland. Okay? Inland. So, could a wave, a tsunami, so big where it washed the crab into 15 miles inland? That's not possible. So, he concluded that the earth is always moving, that under the crust that we live on, there are continuous earthquakes. There's earthquakes that are always shaking. And these earthquakes are the reason why the land masses in the mountains are created. Because it shakes each other and it creates the mountain range. In California, we have the Sierra Nevada. Sierra Nevada is the is the mountain range where we have Sequoia National Park, we have Mammoth, we have Yosemite, we have Lake Tahoe. All those are along the Sierra. Now, all that is because of this plate. It gets pushed up, and because of the earth. Now, did Darwin know that it was actually not earthquake? It was actually plate tectonics. Okay, plate tectonics. These plates here. Now, but he thought it was earthquake. But he was pretty close, right? Pretty close. So as he observed this movement and collect all of these fossils, he concluded that the world changes all the time. It changes all the time. After a long period of time, it takes a long period of time for the species to change. He also found species where he thought, hey, maybe species that are fish, for example, are able to slowly adapt to land, or maybe land animals slowly adapt to the ocean. And so he started observing some of the species, and he found that there are species with parts that shows signs of adaptation to land, and sometimes adaptation to the ocean. Okay, notice how all of these fish, they seem like they have wings, right? These two guys have legs where it's able to get on land and find another body of water to get in. Now, here's an example of what he concluded of the whale. Now, these are the ancient whale. Now, it is believed that, and I think it's supported now, that the current whale came from land. If you look at the whales, if you look at these fins, these here, and you remove the skin, you'll find that it has fingers. But over time, they don't need fingers if you're swimming. They fuse together, creating something to paddle, right? And so it is believed that the modern whale came from a species that used to live on land, and it was easier to find food in the ocean. Now, here's a fossil of a species of a whale, just the bone. Now, you see these legs here? If you remove, this is a whale, this is an actual whale, okay, guys? If you remove the fins, the skin, the muscle, look at it. Doesn't it look like legs, toes? See? And where is it located? It's right here. It's right here. Sharks. Do sharks have little legs? Yes. Next time you go to the aquarium of the Pacific and you see a shark swimming above you, look under and you'll see the legs. But the legs are just there. It's a vestigial structure. A vestigial structure is a structure that you have that you don't even use. It's kind of like the human appendix, or the human, let's say, the tailbone. Humans, we have tailbones, right? So if you touch your butt, right, and you feel that bone on your butt, that is the human tailbone, right? But we don't need it. We have it, kind of like whales. So does it mean that humans used to have tails? Possibly. But because we don't need a tail. We don't need a tail to balance. The reason why other animals need a tail is for balance. Humans, we don't need it. It's not necessary. Other examples of vestigial structures are structures in humans. For example, if you open your mouth, there's a little bell, right? In your mouth, there's a little bell back here. If you cut it off, does it affect your speech? Does it affect your eating? No, it doesn't. It does nothing for you. It's just there. It is a structure that maybe your great ancestors had it, but because it's not useful, it just stops working. But you still have it. Kind of like the, again, appendix. Okay, how many of you had your appendix removed? Anybody? Appendix. It's right here. How many have had your? No, nobody. Okay, 1/3 of you will get your appendix removed. 1/3 of you. That means that out of 30 people, 10 of you will get that pain one day. It gets infected, and you have to get it removed, or else it blows up, and you don't want that to blow up. You need surgery. You will go into surgery that day if you have an appendicitis. Okay, so people, that is Darwin's adventure. Questions? Are we good? I hope that makes sense. Now, if it was me, right? If I was living